All right, really quick video, Rolles theorem on trigonometry. We're asked if Rolles theorem applies to f of x equals sine of x on closed 0 to 2 pi. So you have to kind of keep in mind what Rolles theorem tells us. And Rolles theorem says, and let me read it to you, it's so nice. It says, let f be continuous on the closed interval ab, that's the square brackets, and differentiable on the open interval ab, those are the rounded brackets. If f of a is f of b, then there's at least one number in c in open AB such that f prime at c equals 0. So that's important in this particular problem, and we'll see why in just a second. So I am going to assess this, and I'm going to check this out. I'm going to say, is sine of 0 equal to sine of 2 pi? And they are equal to each other. They both equal 0. So we can say with some confidence that Rolles applies. So I'm going to apply Rolles theorem here. Let me say this again to you. I've said it a bunch of times. If you get to this thing and Rolles does not apply, stop. Why pursue it? The question is, does Rolles apply? You only prove Rolles if Rolles actually applies. If not, you dismiss Rolles and don't move forward. So here Rolles does apply, so we're going to move forward. So I'm going to say, Rolles says that there's some place at f prime at x is equal to 0. Well, the first derivative of sine of x is equal to cosine x. So f prime at x is equal to cosine x equals 0. So where does cosine x equal 0? So what I do here is just very simply, I go to the unit circle, right? And you should have your unit circle either memorized or with you. And I realize that this is pi halves here, isn't it? And this is 3 pi halves down here. And that cosine of 3 pi halves is 0, and cosine of pi halves is 0. So my answers are pi halves and 3 pi halves. The other question I would ask myself is, do these values exist inside the interval? So are they greater than 0 but less than 2 pi? And they are. So these are my solutions. So I hope you buy all that. Thanks for watching. I'm going to go ahead and do the one f of x is cosine x because it's a little bit more interesting, and I'll post that next. Thanks for watching. If you haven't already subscribed, please do. Thanks, you guys.